All right, the lesson for today is on section 6.7. The purpose statement is use properties of in behavior to analyze, describe, and graph polynomial functions, and identify and use the local maxima and minima of polynomial functions. So that's what we're going over today. This is section 6.7. So, the polynomial in behavior. The in behavior is what happens to the graph as x approaches positive and negative infinity. So if you're thinking of a graph, as x approaches positive infinity is as the graph, the x values get farther and farther to the positive. So positive infinity goes forever this way. What's the graph doing as it goes to the right? And negative infinity is what's happening as x goes to negative infinity, or as x goes to the left, what's the graph doing at the end? So you can see on this one, as we go to the right, the graph is going up, and as we go to the left, the graph is going down. And that can be different things. But if we look at the charts on page 453 in your book, so these are in your book on page 453, and it shows a linear, quadratic, cubic, quartic, and quintic. But you'll see a pattern that develops here. With a linear function, when it's a straight line, it's going up one way, down the other. With a quadratic, in this case, it's going up to the right and up to the left. Now we've done a lot of work with quadratics. We know it's a parabola, and it's either going to look like this where it opens up, or it's going to look where it's flipped over the x-axis and it's opened down. A cubic function will always look this way. It will go up one way and down the other way. Quartic, they're both going up. They could both go down. And quintic, again, you can see that it's going up to the right and down to the left. Again, it could go the other way. But this graph chart really tells us what's happening. So if you look at the chart, and again, it's on page 453, it says p of x, which is our polynomial. It can have an odd degree or an even degree. Those are the only possibilities. Okay? It could have, the leading coefficient could be greater than 0, so positive, or it could be less than 0, which is negative. So, if it's an odd degree, then the graph is going to go opposite directions. You can see here it's odd, it's going up to the right and down to the left. On this one, it's going up to the left and down to the right. If it's odd, they will always go opposite directions. If it's even, they'll always go the same direction, either both up or both down. If it's positive, it will always go up as it goes to the right. So you can see here it's greater than 1, so it's going up to the right. It's odd, it goes opposite, so down to the left. It's going up to the right, it's even, so they both go up. If it's a negative leading coefficient, then it's going to always go down as it goes to the right. So it's down, it's odd, so they go opposite directions, so it's going up as it goes to the left. And here, because it's negative, it's going down to the right, but because it's even, they're both going the same direction. So you really don't need to, when you look at a polynomial, all you need to do is look at that leading coefficient and the degree of the polynomial. So, a summary of this, if you want a summary, it says the leading coefficient. If it's positive, the graph finishes going up to the right. If it's negative, the graph finishes going down to the right. Then the degree, if it's even, the graph finishes in both directions, so either both up or both down. And if it's negative, the graph will always finish in opposite directions, so one up and one down. So if we take a polynomial, f of x equals negative 5x to the 6th minus 4x to the 5th plus 3x cubed plus 2x minus 5, it doesn't make any difference what this polynomial does. As long as it's in standard form, we just look at this term. Because it's even, we know it's going to go the same direction. And because it's a negative leading coefficient, we know it's going down as it goes to the right. So however this graph looks, we just know how it's going to finish. It's going to finish going, because it's negative, down as it goes to the right. And as it goes to the left, because it is the same, it's going to finish going down. Now it can do lots of different things in between here. It doesn't really make any difference. But what we're going to do is we're going to describe the end behavior. And to do that, all you have to do is you're going to put as x approaches positive infinity. So as the graph goes to the right, or excuse me, as x goes to the right, what does the graph do? And we know because it's negative, the graph goes down, and if it goes down, it approaches negative infinity because it goes down forever. Then we're going to put what happens as x approaches positive or negative infinity. So you're going to have two things. As x approaches negative infinity, as it goes to the left, if it's going down, then the graph approaches. So as x approaches negative infinity, it's going down, so it approaches negative infinity. So let's take a look at some others. So my f of x, I don't need to write out the whole polynomial because it doesn't make any difference. All we need is that first term, 6x to the fifth. So again, it's positive. So as x approaches positive infinity, as it goes to the right. If it's positive, it goes up. So f of x approaches positive infinity. And as x approaches negative infinity, because it's odd, it goes the opposite direction. So now it's going down. So it approaches negative infinity. So it's pretty easy to do these. You look at the power, the degree. If it's odd, they go the opposite directions, even the same. And then I look here, it's positive, so it goes up to the right, so positive infinity. And because it's odd, it goes the opposite direction, negative infinity. F of x approach, let's say that, let's go negative 7x to the 8th. Again, it doesn't make any difference what any of the rest of that is. We just look at the term with the highest degree. So this tells me they go the same direction. The negative tells me it goes down as it goes to the right. So as x approaches positive infinity, as it goes to the right, the graph is going down, so it approaches negative infinity. As x approaches negative infinity, as it goes to the left, because it goes the same direction. So again, it goes down, so it approaches negative infinity. So here's what I'd like you guys to all do. And I know I'm doing this for Mr. Hewitt's class, so I'd like the whole class to stand up. And what you're going to do is I'm going to put a polynomial up here, and I'm just going to put the first term. Okay, 4x to the 7th. And what you're going to do is you're going to have your arms tell what the graph is doing. So I know I'll turn this way, so it's the same thing you'd be looking at. It's odd, so they go opposite directions. And the first term is positive, so I know it goes up as it goes to the right, so my hands would go like this. Okay? So what I'm going to do is I'm going to put this up here, and I'd like you guys to immediately throw your hands up in whatever direction they should, and then kind of look around. I'll give you a little bit of time. You can look around and see if everybody agrees. And then I'll show you what the answer should be. So go. So let's see if you're right. It's odd, so your hands should be in opposite directions. The degree is odd. And it's a negative number, so it should go down as it goes to the right. So as I go to the right, I'd be down, and I'd be in opposite directions, so I should be like this. All right, let's try another one. 6x to the 12th power. So, go with the hands. Look around, see if you think you're all right. Even power, your hands should be the same direction. Positive, so they should both be up. All right, let's try another one. Negative 7x to the 5th. Okay, go ahead with the hands. Check, see if you think you're right with everybody. Odd, arms should be opposite direction. Negative, it should be going down to the right. So we should be down to the right and up to the left. Let's try one more. Let's go f of x equals 13x to the 11th. So go. Check around you, see if you're correct. Odd power, your arms should be going opposite directions. First term is positive, so it should be up to the right and down to the left. So hopefully that makes it clear on this. But again, how you're going to write this as, all you do is as x approaches positive infinity, so that's saying what's your graph doing as it goes to the right. F of x approaches, it's going up because it's positive infinity. As x approaches negative infinity as it goes to the left, since it's odd degree, it goes the opposite of this. So f of x approaches negative infinity. So that's what the leading coefficients, when they ask the end behavior, that's what you're going to be doing on that. The next thing you're going to do, you're going to be graphing a polynomial. And they give you the steps in the book, but you're going to find the real zeros in the y-intercept, exactly how you've done on the last two sections on 6.5 and 6.6. You're going to plot any x and y-intercepts, so the zeros in the y-intercept. You're going to make a table of values between the real zeros, and then you're going to plot the points from your table, determine the end behavior, and sketch the graph. So, let's look at this example. X cubed plus 3x squared minus 6x minus 8. Well, we can talk about the end behavior already because we look at this, it's degree 3, so they're going opposite directions, and it's positive, so we know as x approaches positive infinity, as it goes to the right, it's positive, it goes up. F of x approaches positive infinity. And as x approaches negative infinity, because it is an odd power, they're going to go in opposite directions. And so f of x approaches negative infinity. So we know it's going to be finishing going up to the right and down to the left. So now what we're going to do is go through, make a chart. We can do that. Remember the y-intercept's easy because it's when x equals 0. So if I plug in 0, you always get the constant. So when I plug in 0, I get negative 8. So that's our y-intercept. So now we're going to go through and find the zeros like you've done before. Now, I'm going to do this way I've taught my classes, so Mr. Hewitt's class is done different. But it's the same thing you did on 6.6 and 6.7. So, we take there is no greatest common factor. We can't factor this, so we take the factors of p, which is our constant term, which are 1, 2, 4, and 8. Our factors of q, which is our leading coefficient, which is 1. And so our possibilities are plus or minus 1, 2, 4, and 8. So those give us our numbers we should try. And we can figure out the number of possible positive solutions by doing the sign changes. So it starts positive, stays positive, goes to negative, so that's one sign change. Stayed negative, so we have one sign change. So there should be one positive number, but again, that could be an irrational number. And if we put in a negative, 3 negatives is negative, 2 negatives is positive, 2 would be positive, negative, so we have negative changes, one sign change stays positive, 2 sign changes. So negative, there would be 2 or 0. Now, if Mr. Hewitt's class hasn't done that, it doesn't really make any difference because we're just going to do synthetic division so we can make a chart and know how to graph this. So, we plug in the numbers. I'm going to start with positive numbers. So we do our synthetic division. And we've got 1, 3, -6, and -8. And I'm going to start with 2. 1, 2, 5, 10, 4, 8. We found a 0. So we know at 2, we are at 0. On this, now remember, you can use the quadratic formula here. This is our constant, first power, second power. So if you did the quadratic formula, A would be 1, B would be 5, and C would be 4. You can plug that in. I always try and see if I can factor this. So most of you use the X method. So 4 and 5, which would be 4 and 1. So X plus 4 and X plus 1. And so our zeros are 2. We got that with synthetic. And then -4 and -1. So I can go back over to my chart and I know at -1 I'm at 0. And at -4 I'm at 0. So we found the zeros pretty quickly. But we can also find out some of the other numbers to find out what our graph's doing. Remember, we know how it's going to finish. It's got to be finishing as it goes up to the right. So you can just plug in numbers in between here to kind of see what the graph's doing. So let's do 1. So 1, 1, 4, 4, -2, -2, we're at -10. So at 1, we're at -10. And let's put in 4 and see where we're getting there with 4. So all we're trying to do now is find points to plot on our graph. 1, 4, 7, 28, 22, 88, and so 80. And so what we're looking for, when we find that number, we know now it's shot up. Okay? If you wanted to, you could put 3 in if you wanted to see if there's a number a little bit closer that we can graph. Because you're not going to graph numbers very high. So 1, 3, 6, 18, 12, 36, 28. So at 3, we're at 28. Let's try some negative numbers. Kind of need to know what's happening in here between this. So let's try -2. Again, remember your remainder is what your value is. So -2, 1, -2, 1, -2, -8, 16, 8. So here we're at 8. Let's find out what -3 is. -3, 0, 0, -6, 18, 10. So at -3, we're at 10. So now we need to kind of find out what's happening past this. So let's go -5. We're looking for, remember, we know it's going to finish going down, so we're looking for a big negative number, so we know there's no more bumps in our graph. So I plug in -5, 1, -5, -2, 10, 4, -20. So it started to drop off. So we have enough points now to plot this. So I'm going to go ahead and erase this. And then we're going to draw the graph. Now we're not going to try to plot any of the big numbers. We know that at 2, we're at 0. And we know at 1, we're at -10. Let's take this down. at negative, at 0, we're at negative 8. At negative 1, we're at 0. At negative 2, we're at 8. At negative 3, we're at 10, so it's still rising there. Then at negative 4, we're at 0. And negative 5, it's dropped off. And we know here at 3, it's going up, so we get our idea of it shooting up there, comes down. And you're just going to connect your dots and get your graph. Because again, we know it's odd, it's going to go opposite directions. It's positive, so it goes up to the right and down to the left. So most of it's the same as what you've been doing on 6.5 and 6.6. We're just going to be graphing it now. Now, some terms that will be new to you. Local maxima and local minima. The local maxima and minima are simply the turning points. So local maxima is the value of a point where the graph turns and heads down. Okay? So we know that's approximately 10. And the local minima is here, and it's approximately negative 10. Okay? So you're just telling those turning points. Now we're going to do this on the graphing calculator. So we can take that equation. We can take this equation and type it in. So I'm going to type that in, x to the third okay, and I'm going to, so they're going to ask you to find the local maxima and local minima. Let's check our window here. Let's go. So sometimes you need to change your window depending on what it's set up as. So let's take a look at this now. And so they're going to ask you to find the local maxima minima using a graphing calculator. So all you do is you type in the equation in the graphing calculator, and then if you go to the trace function, you can just follow along and watch your y values. So right now I know you can't see this, but it says negative 8, and then it says negative 9.1, and negative 9.9, so it's still going down, then negative 10.34, and then negative 10.31, so it started up. So the lowest point I got here was negative 10.347, so I'm going to go negative 10.35. Now, depending on your calculator, what it's set up at, your values could be a little different, but it's all going to be around negative 10. So to find out the local maxima, we just arrow over and we watch our values go up. 7.5, 8.7, 9.6, 10.2, 10.3, and then it went to 10. So I just go back, so it's 10.39. So this would be our local maxima at 10.39, and our local minima would be at 10.35, negative 10.35. So when the book asks you to do this, you're just going to type it into the graphing calculator. If you don't have one, you're just going to have to borrow one. Or when you get to class, hopefully your teacher has one and you can do that. But it doesn't take long because you just type it in and then you trace it and you write down the y values where it's the highest for the local maxima and lowest at the local minima. Now you will have some problems that you type in and it might, let's do this. I'm just going to put one in here. I'm going to change that to the 4th power. And now let's graph that. So now you have this graph and it comes down and it doesn't have a lot of changes. So we don't have a local maximum minimum, we just have a minimum, and there isn't a local maximum. So now we do the trace, and at 0 we're at negative 8, negative 9.1, negative 9.9, negative 10.4. So in this case, it just has a minimum. It's not a local minima, it's a minimum at negative 10.44. And you will come into some, at least on my assignments, that have that, where they don't have a local one, they just have a max or a min, and then you just tell what those are. do in behavior. This is what I'd like you to do on your own. So what I'd like, if you're watching this Mr. Hewitt's class, you're going to identify the leading coefficient, degree, and then tell what the in behavior is. So I'd like the teacher to pause this now, and then you guys do that, and then you can check, turn it back on, and check and make sure everybody's got it right. So, and after you get the answer, check with somebody around you and compare answers and see if you agree. And then when everybody's done with that, the teacher can put this back on, and you can check to see if you did it right. So, our leading coefficient, -1. There's no number, so it's a 1. It's negative. Our degree, it's the highest power, which is 5. And our in behavior, as x approaches positive infinity, well, we know because the leading coefficient is negative, it's going to go down as it goes to the right. So f of x approaches negative infinity. And as x approaches negative infinity, as it goes to the left, because the degree is odd, it's going to go the opposite direction. And so you should have had f of x equals positive infinity. So they would be looking on the assignment, they're looking for the leading coefficient, the degree, and then this is the in behavior. So hopefully that worked out. Now, I'd like you to try number 2. You're going to graph this function, so you have to go through the steps, make the chart, plot the points. So again, teacher can pause this here. You can go ahead and work on that, and then when everybody's had a chance, we can come back and make sure that you have the right answers. So go ahead and pause it here, and then I'll do it, and you can come back and check it out. So, as we do this, again, we take our factors of p, which are 1, 2, 4, and 8. Our factors of q are 1. So we have the possibilities of 1, 2, 4, and 8, positive, negative. We do the sign changes. Starts positive, goes negative, stays negative. So there should be one positive solution. And negative, so it's put in a negative, 3 negatives, negative. 2 plus 1 is 3, that's negative. 1 plus 1 is 2, that's positive, negative. So we have negative, negative, change, change. So it should be 2 or 0. So now we have to do the synthetic division. We're going to keep a chart. We know our Y-intercept. When we plug in 0, you should have gotten negative 8. And because there should be one positive, I'm going to try positive numbers. So let's go ahead and get rid of this. So I'm going to do synthetic division. 1, negative 2, negative 6, negative 8, and I'm just going to start with 2. 1, 2, 0, 0, negative 6, negative 12, negative 20. So at 2, I'm at negative 20. So because it was negative to start with and it's still negative, I'm going to go ahead and go up. I'm going to try 4. One, 4, 2, 8, 2, 8, 0. So we found a 0. Now, if we go back to what this graph's going to be doing, because it's positive, it's going to go up to the right. So I would assume if I plug in a positive number, I'm going to see a big jump. Because there should be only one time it crosses, so let's just try 6. Oh, before we do that, let's go back. Remember, you can do the quadratic formula here to find these answers. So let's find our other zeros. We've got, this was at 4. So we've got, because there's no factors of 2 that add up to 2, so we're going to have to use the quadratic formula. Negative 2 plus or minus b squared, which is 4, minus 4 times 1 times 2, all over 2 times 1 is 2. So we're going to, on this, we know these are going to be imaginary numbers. So we're going to get 4 minus 8. And so we're going to get a negative 4, so we get negative 2 plus or minus we're going to get square root of negative 4 divided by 2. Remember, square root of negative 4 would be plus or minus 2i divided by 2, and since 2 goes into both of those, we get 1 plus or minus I is an answer. So those are not going to show up on our graph because they're not as y-intercepts, so it's not going to cross this x-axis again. So as we go to graph this, there's not going to be any other zeros. So this should be climbing and this should be going down and never come back up. So let's try 6 now. So it's good, you want to find those zeros before you erase this all. So that's why I had to come back. So now we're going to plug in 6. So we get 1, 6, 4, 24, 18, 108, so 100. So you can see it shot up there. And if we go negative, let's go ahead and get 1 so we kind of know what happens in here between. We get 1, 1, negative 1, negative 1, negative 7, negative 7, negative 15. Okay? And now let's plug in some negative numbers. Let's try negative 2. One, negative 2, negative 4, 8, 2, negative 4, negative 12. It's negative 2. So my guess is, if we take, let's try negative 4, it's probably going to drop way off now. So negative 4, 1, negative 4, negative 6, 24, 18, negative 72, negative 80. So we've gotten that point now where it's fallen off. So now we graph it. So if I graph this, at negative 4 we're off, but at negative 2 we're down here at negative 12. At 0 we're at negative 8. And at negative, I think that was 1, that should be positive 1. At 1 we were at negative 15. And then at 2 at negative 20. So, approximations. At 4 we're at 0, and then at 6 we climb up. So this graph you can see kind of does that. So you're just getting an approximation. These graphs don't have to be perfect. Just get a decent estimate of where they're at. If you want, you could even, after you have it, we can type it in here and look at it. So let's type that in, x cubed, x to the third, minus 2x squared, minus 6x, minus 8. And hopefully, it's kind of similar to that. There you go. So you're just getting an estimate. So this actually, we could have put in, we didn't put in negative 1. So because we skipped negative 1, we don't get the exact, and evidently, if you plug in negative 1, we could find that, but it actually went up here, and so did that. But I wouldn't worry about that. You're just trying to get rough estimates of these graphs. When you're trying to find the local maximum minimums, you just type them into the calculator. So if you were to, the last example, use the calculator to do this, to estimate the local maxima and minima. So if you have a graphing calculator, I'd like you to try this. If you don't have one, get with somebody that does. Share the calculator so you can see what they do. So go ahead and try that, and then you can pause this and then come back and turn it on and check. So on this, we go to the graphing calculator. We're going to go to our y equals and clear that and type in the equation. X cubed minus 4x squared plus x, plus x plus 1. We graph it, and then we simply trace. So our trace, I'm going to start over here, so it's at negative 1.5, negative 0.22, positive 0.59, 1, 1.04. So it's approximately 1. I got 1.04. So my local max is going to be 1.04. And now we just keep going over to the minimum. So negative 4.7, negative 5.3, negative 5.7, negative 5.8. So our local min is going to be at negative 5.88. So those, you won't be exact on those, they'll just be estimates. So for my class, you should be doing this. For Mr. Hewitt's class, I'm not sure what his assignment is, if you want to do the same one or not, with the sub below that. So hopefully this helped. Good luck on the assignment.